We've got around 100 amps outside, but I'm charging the vehicle as well, and it's already in the afternoon, 2:15. But 100 amps, this is actually the perfect current to do a bit of a stress test here. Okay, why not? Let's do it. Guys, welcome back to another video here from the Overkill garage in sunny hot Australia. Expected 40 degrees on Sunday, that's in 2 days. So I will have the aircon running then all day long and trying to keep the battery and the equipment as cool as possible here in the garage. But today in the afternoon now we want to do a bit of a stress test for our BMSs, what I have not done for a while. I think I did this right at the beginning when we installed the 3 battery banks here. But as you know, we've got the Heltech BMS at the top, the JK BMS in the middle, and the Overkill Solar BMS in the bottom shelf here. And all of them are fused, or they have breakers with 100 amps there. So as per the initial design of our battery shelf here, we can actually push 100 amps through each battery bank. And we can do this with discharging or charging. So today we want to test the charging functionality of that. And we start with the Heltech BMS here at the top. So the Heltech BMS can actually operate at 200 amps charging and discharging. So this BMS should have no problem at all to cope with this current. All right. And let's go into the Overkill BMS first and turn charging off. Bam. Yep, turn charging off. This is also a good test for the MOSFET functionality on the BMS. So this is now not charging anymore. And once we go back into the Heltech BMS, we can see the current has now increased here to 40 amps. We are still charging with 93 all in total. And we've got a deviation now of 20 to 25, 29 millivolt here. That's fine. Okay, and let's go into our JK BMS. Control 1, 2, 3, 4, 5, 6. Verify, and we turn off charge here as well. So at the moment the charge current coming down through our vertical bus bar there is only going into the Heltech, so into the top shelf battery and the middle shelf. And this BMS, it was just what we have turned off, so there's no charge of this battery anymore. So the current is now split into these 2 battery banks. And I want to turn off the JK BMS as well. There it is off. And we should see now full current, full 90 amps, 91 amps going into the top battery here, right? And the deviation is 40 millivolt. Let's decrease the charging speed a bit of the car here to increase the current. Yeah, 95 is fine. See, and what it shows, 77 only, right? But it's actually 95, 96 amps. 82, so around 80 amps it shows. But we are charging with 100 amps now, and it shows like 82, 84 amps sometimes. So, and I still haven't heard back from Heltech why that is and how to recalibrate the current sensor here, the shunt. But anyway, the balancer has actually kicked in just here with cell number 15. That is interesting. We are over 3.45 volts. And we have got a deviation of 41 millivolts. So I would say that is totally fine at a current of 106 amps now. As I said, the breaker here is 100 amps, but it is actually turned down to 80%, so it's on 80 amps at the moment. So I cannot run this 105 amps for too long, but I would guess around half an hour, 45 minutes would be fine before the breaker starts warming up, and then it triggers and turns off. Yeah, we can see cell number 15 again getting balanced. Interesting. Okay, so far this all looks good here. 30-40 millivolt deviation at this current at 100 amps. Perfect. Okay, let's go back into our JK BMS. We're turning on charging again. Let's have a look what's going on. 71 amps. And now we go into our Heltech and turn this one off. Mine. Settings 8888. And here we do the charging disconnect. Yes, I want to disconnect this. Okay, perfect. And now we see the full 100 amps going into the JK BMS, the middle battery. This one is turned off, the bottom battery is turned off. Full 100 amps through the JK BMS, and we can see the balancer turning on as well. We've got 115 millivolt here. Look at this. That is quite high actually. That is too high. So we need to have a closer look at the middle battery here with the aluminium bus bars and see what's going on. Maybe measure the internal resistance of the batteries, including the bus bars, to find any connection issues between bus bar and terminal of the batteries. So 100 millivolt deviation is a bit too much. Yeah, nothing balances at the moment. Yep, there was a quick balancer. So only above 3.45 volts. Interesting also that it shows only 43 amps while we are actually charging with 99 amps here. Ah, no, you know what? This is a feature of the Heltech BMS. When you manually turn off the charging or discharging MOSFETs, they come back online after a minute or two or so, and that's why the current has now decreased here in the JK. Damn it. So we need actually to go into the Heltech again and turn this off again. Yes, successful. Ah, there we go, 100 amps. Yeah, that is too much. 117 is a bit too much for my taste. They need to look into this. And I just realized all the solar charge controllers, they have entered absorption stage now. Even we have only 70% state of charge because of the voltage drop here across this one battery bank. They thought, well, it's time to go into absorption. We have reached the voltage. Look at this, 55.2 volts. Insane. Okay, apart from that, nothing is really super peaking here at 112 amps. So that's all good. Let's go into our Overkill. Turn on the Overkill charging again. There will be an inrush current coming now. 50, maybe not. Okay, we go into the JK. Turn the JK off again. Just confirming, yep, 0. And we have to turn off the Heltech and the top as well. Discharge, disconnect. Yes, success. So going back in here, yep, 100 amps. We need to be mindful, this is only a 100 amp BMS here. I probably increase the charging current here of the Tesla for a moment. I don't want to trigger this BMS here because then the whole show shuts down here. I don't want to risk that. Yeah, this is only a 100 amp 48 volt BMS here from Overkill Solar. They're not making any larger one for 48 volt, unfortunately. And here in the protection section you can see the charge overcurrent is 110 amps for 10 seconds and then it turns off. So we are close to 100 amps now. Deviation is 50. Oh, that doesn't look too bad here actually. 11, 14, 12, 9 I can see. And the state of charge shows me 95%, while the Victron Smart Shunt claims 69 only, which is correct. This is not correct. This is probably what the BMS now calculates using the voltage parameters here in the settings, you know. And it is above 3.33 volts. Yep, and then it expects, well, we must be close to 100% state of charge, which we are not. So you cannot really rely on these BMSs, what they calculate, what the state of charge is. You always have to look on the point of truth, which is my smart shunt inside the battery shelf. which measures the current going into the vertical bus bar basically. And now the Heltech BMS has turned on again. It is annoying. Okay. Success. Okay, we are back to 90 amps. And deviation looks actually pretty good. There's no balancing so far. We have seen 114.7 amps since we are connected. 6.2 kilowatts into the battery. And the temperatures are 35, 30, 37 in the breaker. So the breaker of course will heat up now because we are hitting the rated current now of the circuit breaker. But yeah, so far I cannot see any issues here with this BMS either. Okay, let's turn on the JK again. There we go, 60 amps. And the Heltech will turn on automatically, so I don't need to worry about that at all. Yeah, it's already on again. That is such a funny feature that it only turns off for a few minutes and then it turns back on again. They have actually sent an explanation for that. I need to find this email from Heltech, and I'll put the information here on the screen now, why the BMS turns itself on again even you turn it off. I don't really like this feature because if I manually turn off the BMS, this is for a reason, right? And I don't want the BMS to turn back on automatically again. So yeah, anyway, so far this little stress test here of our 3 battery banks. So I think we have to do some maintenance work, to do some measurement here on the middle shelf battery with the aluminium bus bars and measure the impedance, including the bus bars and the terminals for each of these battery cells here, and see what we can find. Maybe there are some higher resistances somewhere between bus bar and terminal, so we need to find them and yeah, improve the situation of this battery again. This is actually not too important because we have 3 battery banks and they're sharing the love. I will never have 100 amps going through a battery bank under normal conditions unless I do one of these tests or I need to turn off one of the battery banks, but then still we have another battery bank and the current will be shared between these 2 then. And 100 amps is 5 kilowatt. This is 5 kilowatt of charging or 5 kilowatt of discharging for the battery. I'm not having a huge load on the system here, or I charge in full sunshine as I do right now. But this afternoon, just for the sake of testing, I wanted to measure the full power here going through these battery banks and see if there are any major issues. So top battery is fine, this one needs some attention, and the bottom battery is fine as well. So the next test I want to do this afternoon here. Usually I'm not at home at this point of time, and we've got full optimal sunlight now on this side of the roof here. But as you can see, we are producing only 2.55 kilowatts. It's maybe a bit too bright here. There you can see it better, 2.55 kilowatts, right? And this is a 3.2 kilowatt system. 8 Hyundai shingled panels, 400 watts each. 2 of them in series and then 4 strings in parallel. There are the 4 strings. But I think we should produce a bit more than only 2.5 kilowatt now, right? We've got the optimal, I mean, there's no cloud, nothing, pure sunshine. So let's connect to our Big Shed solar charge controller, 2.5 kilowatts we are making. And what I want to do is now turn off 3 of the strings and watch the power output of 1 string only. 700 and, no, hang on. It needs to find the maximum power point again. 625 watts out of 800. This is the string furthest this way. So let's turn on the second one and turn this one off. There's the small peak, 618,593. See, this one has actually less power than the one at, oh no, hang on. 610, 15, 18. Yeah, 620, so it's the same power output of this string, 622, 624, yep. And the other one was 625, so that's good. Okay, let's see if we get another 620 something. 625, 26 for this one. Yep, they're all producing the same power, it seems. Okay. Yep, that all looks good. And the last one, this is the one right above us. This one produces a tiny bit more, but that's fine. There could be some leaves on the solar panels as well. I've never cleaned this side here since the installation, so it might be time to get up and do some cleaning or something. 630 for this last string here. So that all seems to be fine. If there would be a problem with one of the panels, one of the strings would show a lower power output now, right? But the output of all the strings is within 10 watts. So that is very close together. Okay, that is all fine. Let's turn this all back on. And I've done similar tests to the other solar strings as well, just to check them and to see if they're all performing at their maximum power. And they were all good. But as I said, this one here, usually I miss when I come home from work. There's already some shading going on, or the sun is so far down that the power is not there anymore. But now we've got optimal full power, 2.5 kilowatts here on the system. Nice. Well, and we cannot see this anymore now because we got some shading on the west roof already in the afternoon. But I need to show you this in a different video. There is something going on between these two roofs here. Yeah, they have both 10 of these panels each. The Hyundai shingled 400 watt panels, 2 in series, and then 5 in parallel, 5 of these strings in parallel. I can see a difference in power output of around 250 watts more from the west side to the east side, even if the sun is perfectly in the middle. So the angle on both cells is exactly the same, but it's around 200, I would say it's 150 to 250 watts more from this side than from this side. And I was wondering why that is. And now you probably start commenting already and saying, well, there could be voltage drop somewhere, so this one is performing a bit better because the cables are better connected or shorter or something. Actually, that's not the case, because all these cables going into the combiner box over there, and then we've got this long cable all around in the conduit around there, and then coming down into the solar charge controller, going through the fuses there and going into the solar charge controller. While the east roof over there is connected through the breakers to our combiner box over there. See, this is only 1 meter of cabling, while this one has about 5 meters of cables, but it produces 250 watt more power under the same conditions. And I'm really not sure why that is actually. So I want to do a detailed investigation in one of the next videos when we have the sun exactly in the middle of the garage. And at this point, I'm not sure if this is just a tolerance of the solar charge controllers, because this one usually gets even hotter than this one. So it should perform actually worse than this one, but it's not. It's performing better. So this all doesn't make sense to me. And I had a look in the VRM and the advanced tab and watched the voltages and everything, but I couldn't really find any issues or something. And I also did the same combiner test here, so turned everything off but one string and compared them all together, so they all have the same output. It's all good with them. And the same with the west roof here. I don't know, this is something for another video here. So today just a quick stress test of the BMSs here to see if all the connections are okay, the BMSs are working as expected, and the solar string test on the big shed as well. So this is all good. And as always, guys, thank you so much for watching. Thanks for all your amazing support. Thanks for all your generous donations, keeping me with cold beer here in the garage, refreshed, so I can make more videos for you guys. Thanks a lot for all your donations. And guys, until the next video, you stay charged, stay cool, stay safe, and thanks again for watching. See you then. Bye bye.